Hello and welcome to today's online Python tutorial session. In this tutorial, we are going to treat NumPy. So yes, I'm going to use this document as a guide. I got this document from Google. I think the source is IntelliPath, right, from Google. So I'm going to use this as a guide. So yes, let's move on. NumPy is an open source library in Python consisting of multi-dimensional array objects, and a collection of routines for processing those arrays, right? So what NumPy does is that it provides you, the user, the avenue of storing data in the form of array. You can have your one-dimensional array, two-dimensional, three-dimensional, and so on and so forth, and has various important features or methods or functions needed to manipulate these data or perform some operations on them, right? Your operations could be in the field of trigonometry, algebra, and so on and so forth, right? So NumPy is also a very important tool, especially in the field of machine learning, deep learning, since you always have to pre-process your data in the form of some need the data in the form of two dimensions, in the form of three dimensions before they can learn them. Some of the models, right? Before they can learn them. Also, before you do visualizations, it is important to also store your data in the form of vectors or some one-dimensional arrays, right? As your independent or dependent variable, right? Your dependent and independent variables should be in the form of vectors, right? Before you can, get a good visual or visualization on them. So yes, let's get some things done. So yes, I said that NumPy is an open source library, right? So it is before you always or before you can use NumPy, you always have to import it into your working environment, your work area, right? Or wherever you're working, right? And before you can even access it, it should be installed or it should have been installed into your environment. And the command for installing any library in Python is the pip install, right? You have to ensure that you bring the exclamation mark. So you hit pip install and then the name of your library, right? Since I've already installed NumPy, this is the prompt I get, right? But while installing or before you install, kindly make sure that you have access to an internet connection, right? So after you install, then you have to import the library into where you are working, right? So the command for doing that is the import, then the name of your library, which is NumPy. Then since NumPy or libraries in Python use the dot notation in order for you to access their methods, functions, or properties, right? It's always advisable to give it an alias, right? Mind you, you have a lot of libraries, right? Like for example, a library like matplotlib.pyplot. You see, that is very long. So before you can type that, it's very cumbersome to do that, or it's very boring, right? So you always have to give it an alias, right? And the normal alias uh, we use in the community is NP, right? It's more of a tradition, but you can give it DW, DQ, but you see, for simplicity, just give it NP, right? So that you can easily remember. Then you run it, right? So after importing it, you can use NumPy. Right. Let's look at some of the things we can use NumPy for. So yes, n-dimensional array. You can create one-dimensional array. You can create a 2D array and a 3D array as well. And the way of doing it is that you use this code np dot, right. Remember, np is our alias referencing NumPy. So, and then the dot, right? We need to access some methods. So this is a concept in object-oriented programming, and we will treat it in the subsequent tutorial, right? So whenever you have a class, when you bring the dot notation, you are able to access any function. So the function for creating an array in numpy, right? Python is this np.array. Since it's a function or a method, you have to bring the pair of parentheses, right? So when we are creating a one-dimensional array, it has to be a list of, you know, anything, right? In this case, we have a list of integers ranging from 1 to 4, right? So since it's 1D, the square bracket is 1, right? So we can try it along. Let's get a variable and check if this thing is working. Yes. So let's get a variable a1, then np.array, then we bring a list, right? So mind you, I forgot to mention you can store any data type in a numpy array, right? So I can have a list of string. So yes, let's view a1, right? A1 gives me a one-dimensional array. I can also have a1s, right, as np dot. Let's get some strings, maybe some names of people, right? So John, we can have Kofi, we can have James. Then you run it, control enter. Let's view what we have in the second array. We have a list of, we have an array, a one-dimensional array or a vector, right? A row vector of names, right? John, Kofi, James. And yes, we'll come to the data types soon or later. So let's go to 2D arrays and let's do same. I can just simply copy this for simplicity, right? So for 2D arrays, it's the same conversion, but you have to get a parent square bracket, right? Then within that parent square bracket or parent list, you have lists of the members you want to, um, have in your 2D array, right? So in this case, every list here or each list is a row, right? So this first list becomes my first row, this second list becomes my second row. Let's try this. So remember your parent bracket, right? The parent bracket. Then let me simply repeat this guy here, and then I can maybe change one or two. Then hey, remember, don't be repeating variables or else you get some of your variables overwritten. So yes, we have a 2D array over here. So a 2D, remember from your basic algebra, right? A 2D array is a matrix, right? It's a matrix, right? So a matrix is an n by m what array, right? So in this case, I have a what? I have a 2 by 3 matrix, right? I can have um, a 3 by 3 matrix and so on and so forth, right? So let's look at the 3D array. So in this one, we have two parent square brackets before our members come in, right? And 3D arrays is mostly used in the field of deep learning, right? Because some of the models like the recurrent neural network models, specifically the LSTM models, which is used for time prediction, requires you to pre-process your data in the form of 3 dimensions, right? Before you can train it or it can learn it efficiently, right? So let's say array 21. Let's let's copy this guy here and then repeat this one over here, right? So remember I said it should be within two parent brackets. Is that fine? So and let's display it. You can choose to print it, but as you go along, you can simply display it there. So yes, we have a nice 3D array, right? And so yes, there's one thing you come to, which is viewing the shape or the dimensions of an array. So let's confirm if indeed what we've created here or what we created here were the right or expected arrays we wanted. So let's see something like, and to view the dimensions or the yeah, to view the dimensions we use um, a property called the shape, right? So A2, I'm viewing the second array we created, which was our two-dimensional one. So you see that it's returning a tuple of 2 comma 3, which is telling me that my matrix contains two rows and then three columns. Remember, the one on your left is always row, and then the one on your right is column, right? Or the number of columns you have. And so let's see that of the three-dimensional one, right? So I have 1 comma 3 comma 3. Yes, so this has, so let me explain this. So the one over here signifies the number of records or the number of samples you have, right? Which have the dimensions of 3 by 3, right? But in this case, the 3 over here is not necessarily the number of rows, but rather the time step, how far back you are looking in time. Or yeah, so basically you can take it as that when you are doing time series analysis, right? And then that feature or that record you are looking at should have three columns, right? So yeah, that's a deep learning something. So let's go on. We've learned how to create an array. Let's look at some interesting things that numpy can also do. So yeah, np.zeros, right? We want to create a zero matrix containing three um, rows and then 8 columns. Let's try this over here. Uh, so let's say nz is equal to np dot zeros. Hey, sorry, zeros. Then 3, 8. So yes, run it and then right. Well, I thought this could be, let me try something and see. Yes, it still works with the square brackets, right? So you can do the same thing for ones. In this case, it does not become zeros. You get ones, right? So let's try the same thing for ones, right? And it worked. We run it. So yeah, you get ones, right? So if I want a matrix, like I want a 3 by 3 matrix of fives, right? I can simply do something like 5 times this, and I have a 3 by 3 matrix of fives, right? And we also have here the a range function, right? Or the method. So what the a range does is that you get a list of numbers, right, from 1, then with an increment of 5, 5, 5, right? So a range of numbers from 1 to 30. How many of them can I get when I increase them by 5? Is the 5 is not the number of members here. So let's confirm 1, 2, 3, 4, 5, right? So let's try one over here. So W2 is equal to a range, right? A range, sorry, I have to bring the NP because it's a numpy function or method, right? So yes, start stop. So I want to start from 2 and I want to end at 20 and increment them by 5 or increase them by 5. So Yes, you have 2, 7, 12, 17. So that's what the A range does. Normally we have one, not in numpy, but it's a default function in Python called the range function, right? So but that one, so you can use that one inside numpy too. So let's see what the range function does. So for the range function, that one is unique for integers, right? That one you cannot get float inside. What do I mean by this? So for this, if I make this 2.4 end at 24.8, right? Take note it will end before this because depending on how I increase it, right? When I run it, I get what, a list of floats or an array of floats, right, between this range, right? So let's do one for range. What the range does is that it takes your what, start, stop. No, let's not go that far. Let's make it, yes, and then so start, stop, and then your increments, right? So take note, it always will end at this -1 or minus your incremental over here, right? So when you run it, this is what you get. But if you want to see the list of members you got, you have to use the list function, right? So 1, 3, 5, 7, 9. What if I change this to 12, right? It ends at this, it does not end at this, right? It ends before this. What if I send it to 13? The same thing, right? Let's make it 1 so that you see what I truly mean. So it ends at this guy minus what's 1, right? Depending on how you increment it. So that's how you can use the list. What if I want to do a float? I'm going to get an error because the range function does not take floats, right? It always has to be an integer, right? Which means that I can include this in a what, in an array. So I can create a numpy array around this, right? And have what, a one-dimensional numpy array. So that was just by the way. Let's move on. We also have here the linked space. So what the linked space does is that it gives you a list of numbers, right, or a list of continuous numbers from ranging from your start to your stop by this number of divisions. So meaning if you look over here where my mouse pointer is, the user was simply saying give me a list of continuous numbers from 0, ranging from 0 to 4, right? And I want 8 numbers, right? So let's try one real quick. We can say NLP is equal to np dot length space. Then I said start from 0, end at 4, but I want 100 numbers. It still gives me, which means the numbers are going to be really, really small, right? So yes, you can even create 1,000, but it will really be small. It's not advisable, right? So when you're doing something like you randomly want to train a model and see something, you can use this. Or you want to plot some quick graph, right? You can use this, right? So what again do we have? Yes, we have all these. Create an identity matrix. Create, yes, an identity matrix of 3 rows. And if you want more control over the column, you can use the I. So we have the identity and we have the I, right? Meaning I want an identity matrix having or containing 3 rows with 5 columns. Is that fine? And then yes, the same thing, diagonal. And this is for creating random numbers, right? So this tells me that, or this tells the user, oh hey, create or generate some random number ranging from 2 to 8, but I want three numbers pair. So let's try this. um rk is equal to numpy dot random dot randit, right? Sorry, random integer, right? Give me some numbers between 3 and then 27, and I want 10 numbers b. So let's see what we have here. Run it, and then you see it gives me 10 numbers. If I want to see the length of the array, I can use the length function. It tells me that it's 10. Right? Length function is a built-in function in Python used for viewing the length of any lists, arrays, or whatever you have. Right? So it tells me 10 indeed. So you also have the np.random.rand. That one does not return or generate just integer, right? But if you want floats, you can use this. So you see, but that one I'm not sure it's up to 10, right? So let me confirm. Yeah. So it returns floats. If I view the length, it should be more than that. I'm not used to the rand. It's even 3, right? So yes. So those are some of the things you can do, and we have a whole lot of them. Random underscore sample. It depends on the field you are working in and what you want to do or what you want to achieve, right? So yes, one interesting thing about working in Python is that since Python is open source, there are a lot of documentaries out there, right? So for NumPy, for the libraries we have, right? We have a documentary on NumPy, you have a documentary on Matplotlib, you have a documentary on all the ML models we have in scikit-learn, you have a documentary on Dashplotly, all of them. So it makes your research like you have a whole lot of um, space for research, right? So let's proceed. And yes, array dimension. If I want to see the number of dimensions I have in my array, right? You can use the ndim property, right? So yeah, properties of arrays. You can use the ndim property. So let's view the dimension of. We've already done the shape, right? Let's see the number of dimension. So a2.ndim tells me that, oh, my matrix is 2 dimension. That means I have what, a row and a column, right? Let's see that of our friend over here, which is 3D. A21.ndim gives us what, 3. That means I have a 3-dimensional array, right? We've talked about the length, we've talked about the shape, and yes, you can also view the data type. So assuming you have an array of names like what we have here, and we want to indeed see that it's in the data type of strings, right? You can just see that you all say that a1s dot d type symbolizing data type dot name. Show me the data type, right? So strings 160, or basically it's just a string data type. Is that fine? So this becomes necessary. For example, if you've imported data from maybe your pandas, a pandas column, right? It's something in data analysis, right? So you've extracted a column from your um, um, pandas data frame, right? A column that you expected or you expect to be a list of or an array of maybe some integers, right? And then you want to be sure that you can use it, right? Or that column you extracted is in its rightful data type. That's when this property becomes necessary, right? So let me make this one a1s1 a1s1, right? I intentionally or I deliberately made this what strings, right? So let me see if I try to view the data type, it tells me that it is a string. So the next property here helps us to resolve this issue, which is the astype method, right? So this is called casting, right? Casting helps you to convert um, a certain data type to its rightful or expected data type, right? So A1S1, I want to perform a numerical operation on it or a mathematical operation on it. It cannot be done because these are strings, right? So I need to convert it. So I have to say something like I call the variable I stored in this array dot as type. Then I have to pass in the data type, right? Which is int. So you see the quotation marks are gone, right? So yes, that's one thing you can do. A1, you can also view the data type. It's like this. So yes, another important thing, indexing. Remember we dealt with indexing in our previous lesson, right? I think the first one, right? So the same thing. I have a lot of arrays over here. Let's say A21, A21. Yes, hey, that's my three-dimensional array. Now let's deal with the 2D and then the 1D one for simplicity. So I have A1 and I have, where's the 2D one? And I have A2, right? Right. But we may come to this. So let's A1, right, is the same conversion. A1 is a one-dimensional array, so my index is only one, right? So one. The last, of course, the last object is the nth minus one object, right? So I can say len of a1 minus 1 because Python counts from 0. Remember that from our previous lesson, right? Len of a1 minus 1, right? If you want to confirm it, you can just see our last object is 3 and it returns 3 for us, right? You can also do backwards indexing just as we did in our previous lesson, right? Backwards indexing, right? The forward indexing, remember we start from 0. And yes, we also have Boolean indexing, fancy indexing. I'll send you this document so that you read it on your own, right? Yeah, let's look at some array operations, right, in the field of mathematics, right? We can add two or more arrays of the same what dimensions, right? Remember, so right now I have two arrays which are of one dimensions, right? Or we can simply create one real quick. Let's create one. AW1 is equal to np dot array. Then let's say something like lists. Remember I taught you this range, and I want an array ranging from 1 to 5, right? Remember it will end at this minus 1. The same thing, I can have the same thing. Let's to give me an array 2 to 7, right? Let me indeed see that they are of the same length before I run into any error. 5, okay, 5, of course. So let's perform some addition. So AW add. So we can say something like np dot add. The function for doing that or the method for adding two vectors is the add method. So then you have to bring in your arrays, right? AW2. So yes, after running it, you can view it down here, right? 3, 4, 5. So it adds the two arrays element wise, right? You can also perform subtraction. So subtract, I spelled it wrong. Subtract, right? Yes. You can also do some multiplication, multiply, right? You can also do divide, some division, right? Divide, sorry, yes. You can also do some power. You can also do some floor divide. You can also find the modulus, the square roots, the negation, depending on what we want to do. Let's enter the field of trigonometry, right? You can find a sine. So A is sine. You can find a sine of your array by just using the sine method, right? So yes, but these are going to be some way. So I think you have to create. So yes, let's create some array B, um, some angles. So AW, ENG, NP dot array, and let's call some angles. So or let's use the range function. So list, and you can call in range. Then I want some angles ranging from 90 to 720, about 90. Yes. So yes, 630. Yes, that's okay. So we can find a sign of this. So let's say AQ. I'm just giving some random how do we call it, variables, right? NP dot sign, and then let's view what we have here, right? So yeah, you can also do the same thing for cosine, yes, and so on and so forth. Yes. So another thing you can do is that you can also sort your array, right? Let me check if this thing is working. You can also sort your array, right? Let's do the one we just created, AQA1 or underscore sorted, right? Just a normal variable or a random variable. Let's say np dot sort. I think the default is ascending order. You start from the smallest to the biggest, right? So let's see. Sort, then we call or we pass in our um, previous array, right? So it starts from the smallest to the biggest over here, right? What if I want to do it in descending order? This is the way of doing it, right? This is the way of doing it. So so let's try it. So dot, or let's np dot sort, then two columns, then you see, hey, you still get this. Wait, let me give it one. Yes, so it has sorted it in the reverse format, right? So in what, descending order, right, from the biggest to the smallest. So we have here some array manipulation. You can reshape your array, you can flatten your array, you can transpose it, you can concatenate arrays vertically and horizontally, you can split, you can flip. Reshaping is basically you transforming your array into different shapes, right? So remember we have this array A3. Hey, I think A3 is not here. Let me confirm. My three-dimensional array. I don't want to create another one. Yes, it's called A21, right? A21, right? So, but you have to be careful when you are reshaping, right? So remember the shape of this guy here, the shape of this guy here is what 1 by 3 by 3. When we take the product of it, right, it gives us 9, right? It gives us 9. So whenever you want to reshape an array, make sure that the one you are reshaping it into, that those dimensions or the dimensions of that array should be, or the product of the dimensions of that array of the new one should be equal to the previous one. So let's say I want to reshape this into a two-dimensional array. I can only do this by saying, sorry, a1 dot a21 dot reshape, then I want 3 rows and I want 3 columns. You see, it changes it into a two-dimensional array with this dimensions, right? What other way can I do this? 3 by 3 is what? 9. So I can say that, oh, I want 9 rows but 1 column. It gives me a very nice column vector. I can also say that I want, oh, a row vector of 1 row, yes, and then 9 columns. So that's basically the reshaping method. You can also flatten your array. Flatten means that you are changing a higher dimensional array into a single or a just or a row vector, right? You are just changing a higher dimensional array into a row vector or a one-dimensional array. So I think if each one still exists as three-dimensional, we can flatten it. Hey, sorry. Let me see how they did it. Flatten. Oh, I don't have to pass in anything. Sorry. Right. Yeah, flatten. And then you can also do same for the two-dimensional array, right? You can, as you don't have to do that for a one-dimensional array. So if you have a four-dimensional array, you can flatten it. If you have a three or two-dimensional array, you can flatten it. You can also transpose an array, right? And the way of doing that is by using the property T, right? So when I already have a higher or an array of a higher dimension, I can simply say this, right? Remember, this was our three-dimensional array. So basically, your rows become your vector, your column. Sorry, your rows become your column, right? What if we want to do same for? We have a row vector and we want to change it to a column vector, right? I think A1 was our simple row vector, right? If I bring this, you see it does not change to a one-dimensional, it does not change to a column vector, right? So the way of doing this is that as I was creating A1 should have been like a two-dimensional array. What do I mean by this? So let's say A12, hope it does not exist already, right? My parent bracket. This time I'll just pass in one row, right? But it is two-dimensional, right? It's a row vector, but when I view the shape, it is two-dimensional, right? I have 1 row and then 3 columns. In this case, I can simply or I can easily transpose it into a column vector. So this is how it's done, right? You can also concatenate arrays. Maybe you have 2 row vectors, you want to stack them into a matrix, right? You can do it vertically, right? Whereby you get the first array you passed inside the V stack method becomes your first row, and then the second one becomes your second row, right? If you want to do horizontal concatenation, it simply becomes the resultant becomes a what? A row vector, right? You can also split. You can do a whole lot of things, right? You can do some linear algebra stuff, whereby you do some matrix operations, some matrix properties, you solve equations, find the eigenvalues, and so on and so forth, right? And let's quickly look at some data visualization. So yes, the library used for visualization in Python, right, is the matplotlib.pyplot. It's one of the library, right, or the most common library used, right. You have the Seaborn, you have the Plotly, and so on and so forth, right. But the one that is commonly used, right, is the matplotlib.pyplot, right. It's a library used for visualization, right. So yes, as we have here, I created an array ranging from 1 to 200 to 200, right? N minus 1. Yes, to end at 200. And I found the sign of it as my y. So my x is my what? Independent variable, and my y is my what? Dependent variable. My y depends on x, right? So the function is what? Y is equal to sine of x, right? Basically, right? And this is how to plot a simple graph. So remember, this my alias, as I already stated, right? So PLT. You see how the alias becomes important, or where it becomes important, because of how long this guy is. I can't continuously type this, right, or copy and paste. It becomes very long, and it does not show professionalism. So PLT, then dot notation plot. Then the plot takes in the basic um, parameters that the plot function takes is your x and then your y, right? It takes others, but for a simple graph, you just do x and then y, right? And it gives you a simple graph. But for maybe personal reasons, or for to show some professionalism, or to show that you know what you are doing, you have to label it. This is my X services. So the method for doing that is the X label method, plt.x label, and the same thing for the Y. For whatever it takes, the argument should be a string, and it takes only one argument, right? So if I give this a long name to come here, if I give this also any name to come here, the same thing for the title, right? Title, then Y against X. If I finish, then I just show my plots, right? So that was basically what was going on here. You get some Y data and you get some X data, you get some Y data, right? You can generate your Y by yourself, or you can um, perform some operation on your X to get your Y, depending on what you are doing, right? You have different Matplotlib has a whole lot of visuals, right? And we are just doing some basic. If you want to do some how do I call it, some visualizations using the pie chart, right? Remember, pie chart is a visualization under, or it's a visualization for categorical data, right? So I have the string of colors. Maybe I went around taking the colors of the shirts petrochem 2, the colors of the shirts worn by students of petrochem 2 on a Monday morning, right? I get this red, or for students or whatever, right? Red, blue, green, white. So ideally, what I did was I have four classes of colors here, if I'm right: red, blue, green, white, and it repeats like that in different formats, right? So the method for plotting graph or a pie chart is the pie method. So plt.py, right? But the pie cannot take in this array, right? It cannot read strings. So what I had to do was that I think there should be a shorter way for this, right? I had to get the unique classes. So sure, I'm going to get, let me copy this into this file, this notebook. PLT is not defined. Oh, wow. Okay, okay. I have to import this library. So you see, I didn't import this library over here. So I'm getting errors. So I have to quickly import it. Yes, then it should run here. So I had to get the unique classes, right? So let me show you what I was doing. So the classes are just four colors, right? Blue, green, red, white. It arranged them in what alphabetical order, right? After getting the class, I had to count the number of instances of those unique classes. So what I did was I used the concept of list comprehension to do that. So you'll get there in our list in our subsequent lessons, right? It's an iterative method. So I iterated through this array and counted the number of times these unique classes, right, appeared, right? So if I want to view the counts, it tells me that, oh, I have four blues, I have four greens, I have three reds and two whites, right? So ideally this iteration returned this iteration without the len function returns lists of this one list of the number of times these guys appears, but I just have to get the length of those lists so you can see it for yourself. Let's try this, right? So c1 is equal to what? Let's view do something like red. Hey, sorry, right? Red. So it tells me that red appeared three times whilst it was iterating, right? And let's see the number of times for blue. Blue appeared this number of times. So I simply viewed the length because that's what I needed. Since pie chart takes categorical data or it's a visual for categorical data. So that was what I basically did. And I just did a pie chart based on the counts, right? And then the labels, right? The labels for this were the classes, the unique classes I extracted from here. And then I gave it a nice title, distribution of colors, right? Let me say of PC2 or PC3, right? So or distribution of colors in PC3. So just any reasonable uh, title you can give, or simply distribution of colors of the colors, right? So yes, this brings us to the end of this lesson. These are not all the things NumPy can do, right? There's a whole lot. So I encourage you to research, learn, and then practice, right? So thank you for your time.